Okay, this is a video I'm putting together for my year 12 in July 2009. They've been working on C3, chapter 5, differentiating exponentials and logs. And what I'm doing now will relate to that. So it's a lesson for them, as I know some of them are going to be away and miss some of the work. So if we think back first of all to exponential growth and decay, some work we did fairly recently. If we had initially 100 people infected with a disease, and every period of time, so every day, it was doubling. That's the number of people who were infected. How can we model that? Well, we'll say the number of people infected, let's call that Y, is equal to our initial amount, and then doubling, putting a times T in there, and T for the time in the number of days. That would be our model for our exponential growth and decay. Now, you can rewrite this, so rather than there's a 2 to the power there, you can get it so that it's, instead of a 2 there, E is in there. And that's quite useful because we know how to differentiate that. So what we're going to do to start with is we're going to go back to our sort of model we had before, which is Y is some initial value and then a rate to a power. This Y is A, B to the power of T. Now B there, that's just a number, okay? And if we wanted to, we could write B down as E to the C, where C is just another number. Now you might think it's a bit strange at the moment, but we could do it. And if we did have that, if we took logs, and what I mean here by logs is the ln, the natural logs, log of the left-hand side is log of B, and log of the right-hand side is log of E to the C. And from what we did the other day, we know that log and E, they're inverse operations, inverse functions, they cancel each other out. So on the right-hand side, log of E to the C is actually just C. Sorry, log of B is C. So what we've got now is our original equation, which is Y equals A, B to the power of T. I could write down as Y equals A, B, now hang on, what's B the same as? B is the same as E to the C to the power of T. And using laws of indices, what I've got here is E to the C to the T. Now, if we just take E's out of it a minute, if you had before, sort of think back to GCSE, A to the M to the power of N, that was the same as A to the MN. That's a sort of rule of indices. So over here we could write this down now as Y equals A E to the CT. And that is exactly the same as what we had over here. And the key thing was, hang on, where's C come from? C is equal to log of B. So what we have managed to do here is we've rewritten something like this with no E's in it. We've rewritten it like this where there is an E in it. The B, which was a number here, has now been replaced with a C, but the relationship between them is C is equal to log of B. So if you think back to our example we started with up here of our growth, which is Y is 100 times by 2 to the power of T, that's the equivalent of that one there, where A is 100 and B is 2, I could rewrite it in this equivalent here. Y equals now the 100, the A bit stays the same. And here the E, now C, what's C? C is equal to log of B, and B here is 2. So that'll be log of 2, and then the T is still there. So these two expressions are equivalent, they do exactly the same thing. It's just here we've got it with an E involved instead of here with a 2 to the power of T. And it's easier to deal with E to the powers of rather than numbers to the powers of. So we said these two things are equivalent. Just want to sort of demonstrate it really. Let's have a look at what happens when T is 0. That's right at the beginning of the situation. Here in this one, so call this one sort of version 1, I'm going to get Y is 100 times by 2 to the power of 0. Anything to the power of 0 is 1. So I'm going to get Y is 100 times by 1. Y is 100. That's true, that's what we expect. In this version over here, I'm going to get y is 100 e to the log of 2 times by 0. Times anything by 0, you get 0. So that's 100 e to the 0. E to the 0 is 1, so I do get y is 100. Okay, let's see what happens after 3 days when t is equal to 3. In this model here, I'm going to get y is 100 times by 2 to the power of 3. 2 to the power of 3 is 8. 100 times by 8 is 800. So as we expected, after 3 days it's doubled, doubled and doubled, and that's now 800. Let's have a look at what happens with this model. I will have y is 100 e to the log of 2 times by 3. Now I'm going to need a calculator for this one. First of all, if I find the calculator, I need to do log of 2, which is this number here, 0.69, and I need to times that by 3. Now I need to do e to that, so I'm going to do e to the x of my last answer, and that's giving me 8. And 100 times by 8 is 800. So these two expressions over here are equivalent to each other. When you put the values in, I hope I've just demonstrated that to you.